Hello everyone, welcome to today's session. So today we try to discuss something about numerical analysis. So if you follow my channel, you have seen that we have already discussed one method which is called Pickard's method, which is useful to solve a differential equation numerically. Today's class we try to discuss the Taylor series method and some problem related to that. So in this context, I must say that this method is very useful because many other methods will be generated from this method. Okay. So, but if you want to know Taylor series method, the method is very easy, but you need to know the idea for multivariable calculus or the derivative idea for multivariable calculus. So let's give that in the beginning, then we can start the main topic. So suppose z is a function of x and y. Now look into this function. Within the function there are two arguments, x and y. That's why this is called multivariable function. Now if I want to take the derivative of z with respect to x, which means I have to take the derivative of right hand side with respect to x. So that will be fx into plus fy. So this is the basic idea for chain rule. That is, if you want to take the derivative with respect to some particular variable of a mixed function like this, so you have to take the derivative individually and then the derivative of this one with respect to x. So this is the thing. Okay. So basically what I can say there is z. Under z there is a function where two variables are involved, x and y. If you want to take the derivative of z with respect to x, then you have to involve these two variables also. So this one. So what we have done? So z equals to actually f, both are f. So fx del f del x into dx by dx plus fy means del f del y into dy by dx, sorry, dy by dx. So fx basically means del f del x and fy basically means del f del y. Okay. Now with this knowledge we can do the higher derivative also. So basically this is becoming fx, because derivative of x with respect to x is 1 plus fy dy dx. Fine. Now suppose anybody want to take the higher derivative d2z dx2, that is the derivative of this one again with respect to x. Now there are two parts. First is fx, this we have to take the derivative with respect to x. Another is the second part where u into v form is there, right? So if I concentrate on the first form, so basically we have to find this one ddx of fx plus ddx of fy into dy dx. Okay. Now if I go for the first one, say ddx of fx, carefully you see, this is very important. See, many people can think this is fx, so only x will be there. No, that is not the case. Suppose f is x square y, so what is fx? This will be 2xy, but y is there. So under fx is only a notation. Under fx, y may be there. So what will be the derivative? The derivative will be the same logic. Derivative with respect to x into dx plus derivative of with respect to y into dy dx. So what we have got? We have got fxx dx dx is 1 plus fyx into dy dx. Fine. So first one we can understand. Then the next one, if I want to show ddx of fy into dy dx. Now let this become, we take u and v form. So basically this is ddx of fy and dy dx is constant plus fy is constant, ddx of dy dx. Now look into the first one. What about the first one? The first one will be again derivative of x, a derivative of this one with respect to x into dx dx plus derivative of this one with respect to y into dy dx, and dy dx is constant, plus fy, there may be d2y dx2. Okay, so in this process we can get the idea for multivariable derivative. Now let us come back to the main situation. So why this multivariable calculus is needed and how we can solve this Taylor series problem. So what is a given problem? A given problem is to solve y dash or dy dx equals to f of xy and y of x naught equals to y naught. So this problem will be given to us and we have to solve this using Taylor series method. Now here x naught is the, this one is the initial condition. Okay, so this is the basic problem. Now what is Taylor series? So according to Taylor series, any function say y of x, it can be written infinitely around any point x naught. So what will be the expression? Y of x naught. So what I am telling, y or any function can be written infinitely around the point x naught. That's why x naught should be there within bracket. If it is around the point 0, so it should be y within bracket 0. If it is around the point 1, it should be y within bracket 1 plus x minus x naught y dash x naught plus x minus x naught square factorial 2 y double dash x naught and so on. So this is very simple, like binomial series. So y of x equals to y of x naught. So x naught is this x naught plus x minus x naught y dash x naught. So y dash x naught means y dash x naught, that means f of x naught and corresponding y value y naught, okay, and so on. Now we have to understand that what is this is telling, what this is telling. So what will be the next term? The next term will be x minus x naught whole cube by factorial 3 y triple dash x naught and so on. Now there is no problem, there is no problem, there is no problem. Only we have to understand what is y of x naught, what is y dash of x naught, what is y double dash of x naught, what is y triple dash of x naught. That we will be discussing now. If I came for the first one, y of x naught, what is y of x naught? It is given in the problem, y naught. So this will be given. So this one is okay. Now if I want to say y dash of x naught, what is y dash means? This means dy dx at x naught, and if x is x naught, then y should be y naught. So it is the point x naught y naught. Now what is dy dx? Dy dx is f. So this will be nothing but f of x naught y naught. So this one is also clear. I think this is okay, fine. So first two term there is no doubt. This will, you can get directly from the condition. y of x naught is the first term and y dash of x naught you get from the main differential equation. Now let me just rub this one and start calculating the third term onwards. So the main problem is y dash double dash x naught. Now you see y double dash x naught, this basically means derivative of this one. This basically means, so let us find y double dash first, then x naught will come. Y double dash means derivative of y dash, so this means d dx of y dash, or this means d dx of f of xy, because we know y dash is f of xy from the differential equation. Now what is that? That will be again from the chain rule, you have to find, so fx into dx dx plus fy into dy dx. Now this is fx, dx dx value is 1 because the derivative of x with respect to x is 1, plus fy. Now carefully see what is dy dx. So what is the equation given? Y dash equals to dy dx equals to f of xy, and the condition given y of x naught equals to y naught. So what is dy dx? That is nothing but f of xy. So this is f. So when I am writing this, within bracket xy is there, so I am not writing that, just the function. Okay. So y double dash, we are getting fx plus fy into f. So let me just write here actually what we are getting. We are getting y of x naught equals to y naught, this will be given, y dash equals to f of x naught y naught, and y double dash is the formula fx plus fy into f. So everything we have to calculate. Now if I go for y triple dash, we will show the calculation. So that means this is d dx of y double dash, because if you take one more derivative you take triple dash. So that means it is d dx of this one fine. So what is that? So that means it is d dx of fx plus d dx of fy into f. So I just separate this one. Now look into the first one. So this function you have to take the derivative with respect to x once, with respect to y once. So it will be, if you take derivatives, it will be xx into dx dx plus f of yx, that is fx was there, we have taken the derivative with respect to y. So yx into dy dx. This is the first term, plus now this is u into v form. So basically if you have to take fy constant, now d dx of f plus f constant d dx of fy. This is u into v form, right? So if I just simplify, so y triple dash, what we have got? We have got fxx, dx dx is 1 plus fyx into dy dx means again f. Okay. So first term we have got, plus look into the second term fy. Now within bracket what will happen? We have to take the derivative with respect to x, but f means there should be x and y both. So again it should be fx into dx dx, that is 1 plus fy into dy dx, plus f is constant. Now this one we have to take derivative with respect to x. So basically we have to take derivative with respect to x and y both. So what we have got? We have got, first if I take the derivative with respect to x, plus f of y into dy dx. So now it is a very big expression, so you should note down carefully. So what we have got? We have got fxx plus fyx into f plus fy into fx plus fy into dy dx means f plus f into f of xy plus f into f of yy dy dx means another f. So this is y triple dash. So we can see that how we can calculate y triple dash, and you can calculate furthermore, but you have seen that this derivative expression is very big and complicated. So that's why commonly we are not using Taylor series, we are using some other method rather than Taylor series. But we will try some problem and let us see up to second derivative at least we can do very easily. So we can do that. So just I am erasing this one. So if I go for a problem, say solve dy dx equals to x cube plus 2x y square plus y cube, y of 0 equals to 1 at x equals to 0.2. Now please always remember, those who are doing the differential equation solution first time, you remember when this type of situation will be there, first of all your goal will be on the differential equation and the condition. This at position will be at the last. So don't be bothered about this at position, this will be at the last. So first you have to solve this one. So if I want to solve this one, so first of all we have to understand what are the things are given. So what is f xy? F is dy dx equals to f. So f means this one, x cube plus 2xy square plus y cube. What is x naught? X naught is 0 and y naught is 1. So this is x naught and this is. So these things you have to understand in the beginning of the problem. Now what was the Taylor series method? According to the Taylor series method, the solution was, so if I go for the Taylor series, the solution was y of x equals to y of x naught plus x minus x naught y dash of x naught plus x minus x naught square by factorial 2 y double dash of x naught and so many terms. So now x naught means 0, so y of 0 plus x minus 0, so only x, then y dash of 0 plus x square by factorial 2 y double dash of 0 and so on. So basically we have to solve this. Now what is y of 0? Y of 0 is given 1. Y dash means dy dx. So that is x naught comma y naught. So f of x naught comma y naught. So 0 cube plus 2 into 0 into 1 square plus 1 cube plus x square by factorial 2 y double dash means fx plus fy into f. Now we have to simply put this value. So just I am erasing this one. Now just we calculate what is fx. So what is fx? Fx means 3x square plus 2y square. What is fy? Fy means the derivative of this one partially with respect to y. So it will be 4xy plus 3y square. Now look into this one. So what we have got here? So we have got the solution y of x equals to 1 plus x. What is this one? This is 0, this is 0, so 1. So 1 plus x. So first two term we have written plus x square by factorial 2. Now we have to calculate this one. So fx at the point x naught y naught, that means 0 comma 1, it will be x equals to 0, y equals to 1. So basically fx 0 comma 1, it will be 2. Fy 0 comma 1, because x naught y naught the same thing, so x will be 0, y will be 1, so it will be 3. And f 0 comma 1, it will be x equals to 0, y equals to 1, so 1. Okay. So what we have got within bracket? Fx means 2 plus fy means 3, f is 1. So this. Now you see it is very simplified. So what is the final solution? 1 plus x plus 5x square by 2 plus dot dot dot. So we are ignoring the higher order terms. So this is the y of x. This is the solution. Now if you remember, we have given one more part that at x equals to 0.02. So at x equals to 0.2, we will get y of 0.2, that is 1 plus 0.2 plus 5 by 2 into 0.2 square. So you get the final solution. So I think that's okay for this class. So if you carefully seen, we have done many important steps in this problem or in this topic. So what we have discussed before starting this topic, we discussed about multivariable calculus and how you can take the derivative with respect to x and y both. So I think many engineering background people will follow this one. Those who are mathematics honors or mathematics major, they don't have any problem in multivariable, but those who are from engineering background or non-science background, most probably, so they will not know that what is multivariable and all these things. So for them I am telling this, you can think in this way. So we have derived this and we can get the final result. But as you have seen, this calculation is very lengthy. So in next class we will go some alternate method which is generated from Taylor series method only. Thank you very much.